All right, welcome to Notes on Solving a System of Equations by Substitution. This is 3.2 for us in intermediate algebra today. We are going to go ahead and get started. The first thing I want to do is I want to do a quick warm-up. I want to get your brains going here. And so we are going to solve this system of equations by graphing. And I have x plus y equals 4 and a 2x minus y equals 2. And I want to solve those by graphing. And as you remember, I want to take those and I want to graph each one of those equations. Well, the first one is x plus y equals 4. And I know I want it into y equals mx plus b form, what we call the slope-intercept form. So I want to move this x, I'm going to move it to the right-hand side of the equation. And I do that by subtracting what I do to one side of the equation. Remember, I have to do to the other. So this ends up being y equals a negative x plus 4. And that says I have a y-intercept of 4 and a slope of a negative 1. Remember, if I've got a negative x, that is a 1 in front of that x. So therefore, I have a slope of a negative 1 over 1. So I'm going to go ahead and let's see, plot my y-intercept. I lost my train of thought there for a second, but you can know me. And so we're going to plot that y-intercept. It is a point 4. We're going to plot it. My slope is a negative 1, so I'm going to go down 1 and over 1. Remember, a negative slope is going to go down and to the right. I could go ahead and plot another point. I could go up and to the left. That is a negative movement as well. And I can do a couple of those. Down and to the right, down and to the right. I probably have enough to graph. Draw my straight line, and away I go. The second one, I have 2x minus y equals 2. So 2x minus y equals 2. Once again, I wanted the y equals mx plus b form. So I'm going to take the 2x, I'm going to move it to the other side. This leaves me a negative y equals a negative 2x plus 2. Remember, I always want the x in front of the number. I want it in y equals mx plus b form. So I definitely want that x up front. Well, this says negative y. Not y, but negative y. We can't have negative y. It's not y. It's not the same thing. So I need to go ahead and divide by negative 1. Remember, if there's a 1 attached to the y, in the negative form, I want to divide by that negative. Well, I have to divide by that negative all the way through. So that gives me y equals negative 2 divided by 1 is a positive 2. And a positive 2 divided by a negative 1 is negative. So basically, all I've done is switch my signs around. I have a y-intercept of negative 2. Go ahead and plot it. And I have a slope of a positive 2, which means it's a positive 2 over 1. Up 2 over 1. Up 2 over 1. I have 3 points. More importantly, I have a point where they intersect. And as you remember from your homework from yesterday, I have where the two lines intersect, this crossing, this point where they cross or intersect is my solution. That is my solution to this system. What happens to be at the point 2, 2? I can always check that. I can check to see if my math is correct by plugging that into both of those equations. Well, in the first one, I've got an x plus y equals 4. Well, that ends up being 2 plus 2 equals 4. We know 2 plus 2 is 4, so it works for that one. I can do it for the second one. The second one is 2x minus y equals 2. Well, 2 times 2 minus 2 equals 2. Well, 2 times 2 is 4. 4 minus 2 is 2. So I know that my solution to 2, where the two lines cross or intersect, is the correct solution to this system of equations. All right, moving to the next page. We got our brains working. We're warmed up. Now we're going to go ahead and I've written out these steps for solving the system of equations by substitution. I want you to go ahead and pause, write these down, and then we're going to talk about them, and we're going to show you how that is done. Okay, so go ahead and pause right now and write them. All right, welcome back. So the first one says solve for one variable and then at least one equation. What that is saying is that I want to get a y or an x by itself. I want it by itself. The second one, it says substitute the resulting equation into the other equation. When we get to the problems, you're going to see that. Step 3, solve that equation to get the value of the first variable. Meaning that whatever I wanted by itself, I've got to plug into the other equation and solve for the only variable present, the only variable there. Once I have that answer, I'm going to do step 4, which is substitute that value into one of the original equations and solve. When I get that answer, I'm going to go ahead and write the answers from numbers 3 and 4 as an ordered pair. So your answers should look like an ordered pair, just like we saw when we solved them by a system of graphing, solving the system of equations by graphing. When we graphed them, we got an ordered pair as our solution. We're going to get the same thing when we do it by substitution. All right, so let's see some examples. First one, kind of using this idea, solve each equation for x, meaning I want to get x by itself. Well, in the first one, let's see y equals x plus 3. Well, that x is not by itself. It's attached to the 3, but it's attached to the 3 by addition. I want to not have it attached to the 3 by addition, so I must subtract by 3. And what I do to one side of the equation, I must do to the other, so this becomes y minus 3 equals x. Well, that x is by itself. And so I've done what it's asked me to do, and that is solve each equation for x, getting x by itself. The next one, y equals 3x minus 4. Well, it's attached, the x is attached to the 4 by subtraction, but it's also attached to a 3, but that 3 is attached by multiplication. I need to get rid of the subtraction first before I deal with the multiplication. So I'm going to go ahead and add 4 to both sides. What I do to one side, I must do to the other. So this becomes y plus 4 equals 3x. Now remember that this x is attached to 3 by multiplication. So what I want to do is I want to divide by 3. The opposite of multiplication is division. So I'm going to divide by 3. Well, as I divide by 3 on one side, I must do it to all the sides. So that's going to leave me my x by itself. Well, the number in front of the y, and that is a y right here. That is a y. That number in front of the y is a 1. So this becomes 1/3 y. And then the other one is a 4 divided by 3. Well, I've accomplished my goal. I've gotten x by itself. And it gave me the answer of 1/3 y plus 4/3. Okay. So you're going to be asked when we do this by solving systems of equations by substitution, you're going to be asked to either get an x's or y's by itself in the first step. Let's go ahead and do some. The first one, I have a 3x plus y equals 5 and a 2x minus y equals 10. And a quick reminder, whenever you need to pause, if I'm going too fast for you, you need me to pause or you need me to slow down, just hit the pause button, go ahead and catch up, and then start up again. All right, so the first one, 3x plus y equals 5, 2x minus y equals 10. My first job, my first step is determine which equation I want to solve and get one of the variables by itself. Well, I have a 3x and 2x. Those attached by multiplications. That's not really great to go at for right now, but I've got a y and a negative y. Well, I think the 3x plus y equals 5 is the easiest one to attack first. So I have 3x plus y equals 5. And I can see that if I move this 3x to the other side, that this y will be by itself, and so therefore I'd have a variable by itself. I'm going to do that. I'm going to subtract 3x from the left side, which means I have to do it to the right side. It gets me y equals negative 3x plus 5. A negative 3x plus 5. And so I have y by itself. So now I have to substitute this negative 3x plus 5 into the other equation. Well, that other equation is 2x minus y equals 10. And I'm going to substitute this term, what y is. Y is negative 3x plus 5, and I'm going to substitute in for this y right there. So this becomes 2x minus, and I'm going to put it in the side parentheses so you can see it, a negative 3x plus 5 equals 10. So what I've done is I've substituted this negative 3x plus 5 in for that y. Now all I have to do is solve for the x, because all I have left is x's. So this becomes 2x negative and a negative. Remember, this is a 1. It's treated as a 1 out here. So negative 1 times a negative 3 becomes a positive 3x. And a negative 1 times positive 5 becomes a negative 5 equals 10. I'm just solving for x at this point. 2x plus 3x is 5x minus 5 equals 10. Add that 5 to the other side. Subtract it, or add that 10 and that 5. I'm going to move it up here so we can run out of room. So it becomes 5x equals 10 plus 5 is 15. Divide by 5. Divide by 5 gives me x equals 3. So I've got x by itself, which is 3. I have a solution, or I have one part of the solution, that is x equals 3. Now, I can plug that 3 in to either one of the original equations. It does not matter which one, and I can plug it in and solve to get y. So I'm going to do that. And I'm going to plug it into the 3x plus y equals 5 one again. So I have 3x plus y equals 5. I'm going to plug this 3 right here in for this x. So this becomes 3 times 3 plus y equals 5. This becomes 9 plus y equals 5. Subtract 9 gives me y equals a negative 4. So y equals negative 4. So as you see that, I have now two terms. I have x equals 3 and y equals negative 4. I'm going to write them as an ordered pair. 3 and negative 4. That is my solution. I can always check it by plugging them back into both of them, and I should get 5 equals 5 and 10 equals 10. So that becomes my solution. All right, let's do another one. I have y equals x plus 1 and 2x plus y equals negative 2. All right, so what I notice here is that I have a y by itself already. I don't really have to struggle. I have it by itself. So I can go ahead and start with the other equation. And that other equation is 2x plus y equals negative 2. And I can plug in this x plus 1. I'm going to put it into another color, x plus 1, and I can plug it in for this y of this equation, which means I'm going to go x plus 1 right into the equation, and it's going to be equal to negative 2. So all I've done is substituted in this x plus 1, which was equal to y, in for y. Now I can just go ahead and solve. Combine like terms, do all my orders of operation. So I have 2x plus x plus 1 equals negative 2. 2x plus x is 3x plus 1 equals negative 2. Move that 1 to the other side. Gives me 3x equals a negative 3. Divide by 3, divide by 3. That's going to give me x equals a negative 1. So I have found where x is equal to a negative 1. I want to plug that negative 1 into either one of the two equations. It does not matter which one I do. Well, there is one easier than the others, and that's the top one, y equals x plus 1. So y equals x plus 1. If I simply take this negative 1 and I slide it into that x, I've got a nice easy equation. This becomes y equals a negative 1 plus 1. Well, negative 1 plus 1 is 0. So it becomes y equals 0. So my solution is negative 1, 0. That becomes my solution. And I can double check that. It's pretty easy to check. Negative 1 in for x. Negative 1 plus 1 is 0. That makes sense. So 0 equals 0. And I can plug in negative 1 in for x here. And that would be 2 times negative 1 or negative 2 plus 0 equals negative 2. It checks out. Remember, you can always check this by plugging them back in. We saw that in yesterday's notes, in yesterday's homework. All right, let's do number 3. X equals a negative 2y plus 4 and a negative x plus y equals negative 7. Well, once again, I notice I do have a variable by itself already, and that is the x. So I'm going to go ahead and have that one already out there. But I'm going to go ahead and plug it into the other one. So I'm going to write it. A negative x plus y equals a negative 7. Well, I know I have a negative. I want to plug in the value for x, which is a negative 2y plus 4. And I'm going to plug it in, a negative 2y plus 4. Well, I still have the plus y and equals negative 7 there. But I'm going to go ahead and now distribute this negative. Well, it's a negative 1 times negative 2y, which becomes a positive 2y. And a negative times positive 4 becomes a negative 4. I still have y and negative 7. 2y plus y, combining like terms, the 2y and the y is 3y. Minus 4 equals negative 7. Add my 4 to both sides. 3y equals negative 3. Divide by 3, divide by 3, and that becomes y equals a negative 1. So I have y equals a negative 1. Well, I can, once again, plug that negative 1 into either one of the two equations. It does not matter which one, and go. Well, I'm going to plug it into the x equals a negative 2y plus 4 equation. So x equals a negative 2. We're plugging a negative 1 in for it. And I'm going to still add the 4 to. So this becomes x equals negative 2 times negative 1 is a positive 2 plus 4. So this is x equals 6. So my solution to this is 6, negative 1. Remember, x is always before y is an ordered pair. So our solution is 6, negative 1. All right, let's do another one. Reminder. Always to pause it if you need to. Pause where I get everything caught up and then start it back up. Alright, x plus y equals 9 and 2x plus 3y equals 20. Well, the easiest one I think is to go ahead and get an x or a y by itself up there and then plug it into the other one. So I have x plus y equals 9. I'm going to subtract x, get it into y equals a negative x plus 9. Well, I know from here I want to plug this negative x plus 9 into the y of the other one. So I have 2x plus 3y equals 20. And so I have 2x plus 3. And my y is negative x plus 9. So I'm going to substitute it in. So this becomes negative x plus 9. And it is going to be equal to 20. All I've done is substituted this in for the y right there. That y. So this is 2x. 3 times negative x is a plus a negative 3x. And 3 times 9 is 27. Then it's going to be equal to 20. As I look at this, let's combine like terms. 2x and negative 3x becomes a negative x plus 27 equals 20. Subtract 27 from both sides. This gives me a negative x equals a negative 7. Divide by negative 1, divide by negative 1 gives me x equals a positive 7. Gives me x equals a positive 7. Alright, so as I look at this, I can go ahead and plug it into one of the two original equations. It does not matter which one. I'm going to plug it into the x plus y equals 9. So x plus y equals 9. And I'm going to take this 7 and I'm going to plug it in for this x, which becomes 7 plus y equals 9. Take that 7, move it to the other side by subtraction. Gives me y equals 2. Well, that tells me that I've got an x of 7 and a y of 2, which means that my ordered pair is 7. My y term is 2. And I am all done. I am all done. Okay, we have 2 more examples. I need you to see the other 2. Here we go. Next one. X minus 3y equals 10. 2x minus 6y equals 8. I want to go ahead and get the x by itself for the top one. So this is x minus 3y equals 10. I'm going to take the 3y and move it to the other side. So it equals x equals 3y plus 10. And I'm going to go ahead and plug that in to the other equation. That other equation is the 2x minus 6y equals 8 equation. I'm going to plug this 3y plus 10 in for that x. So this is 2 times 3y plus 10 minus 6y equals 8. Now I'm just going to solve. Let's go blue. 2 times 3y, 6y, plus 20 minus 6y equals 8. Wow. What do I notice here? Well, I notice I've got a 6y and a negative 6y on the same side. Well, 6y minus 6y is no y's left over. So the only thing I have left, because these cross out, they're on the same side of the equation. I can't have 0y, it just goes away. So I'm down to 20 equals 8. Well, we know basic math, and we know that 20 does not equal 8. So this is going to be an example of no solution whatsoever. No solution, which means these two lines, these two equations are parallel to each other. They're parallel. The lines, if we graph these, would be running parallel to each other. All right, one last example. Reminder, pause it if you need to. Catch up, get everything down. Don't forget to ask questions in class when I see you. The last one, y equals 9 minus 3x, and 3x plus y equals 9. I've got a y by itself already, so I'm going to plug that into the other equation. That other equation is 3x plus y equals 9. And I see this 9 minus 3x for y. and I want to plug it in to that equation right there. So I've got a 3x plus. I want to plug that in. It's a 9 minus 3x. And that it's all going to be equal to 9. All equal to 9. So I have 3x plus 9 minus 3x equals 9. Well, once again, I noticed something here. I noticed that I've got a positive 3x and a negative 3x. So as I look at this, positive 3x and negative 3x, they cross out on this side. I can't do anything with those because 3 minus 3 is 0. So what do I have left? 9. What do I have left on the other side? 9. 9 does equal 9. So this is going to be a perfect example of infinite many solutions, or what we also call IMS for an abbreviation, and that's an M, or you can do that for me, the infinite sign. Any of those would work. Any of those would work. Infinite many solutions, IMS, or the infinity sign. All right, last thing on your notes today. Name the 3 possible types of solutions and draw an example. All of those, we've seen the 3 kinds today. We've seen an ordered pair. So the first one could be an X and a Y, right? X and a Y. And that would be 2 lines intersecting. 2 lines intersecting in one location. The second one, we just saw it, that is no solution. And no solution would be 2 parallel lines. 2 parallel lines. They're running forever and ever and ever, and they never cross. And the third one we just saw just now, and that is infinite many solutions. And what would that would be? Well, it's really kind of a cool one. It is just one line. It's one line. So both equations end up being the same line. All right. I hope you enjoyed your notes on 3.2. I'll see you in class. Ask any questions that you have, and we will have some fun doing these.